So good evening everybody. Chemical bonding. First, a very excellent question. What is the valency? What is the valency of phosphorus in P4? If you ask the correct question, what is the covalency of phosphorus in P4? So that is a good question. So phosphorus P4 structure, if you verify P, 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 like this. It is a tetrahedral structure. So covalency in this word only very clearly indicates covalency, covalent bond related. That means number of covalent bonds attached 1, 2, 3 to a particular atom. So therefore the covalency here 3. Okay, that is covalence related. Now here only I will ask one excellent question related to this P4. If PP bond energy, if PP bond energy is X, then P4 bond energy is how much? Then P4 bond energy is how much? If PP bond energy is X, then P4 bond energy is how much? Generally our thinking, sir, P4 sir, 4 phosphorus are there sir. 1 PP bond X, P4 bond energy is 4X. But the answer is 6X. Because it contains 6 PP bonds. So this is first PP, second PP, third, fourth, fifth and sixth. 6 PP bonds are there. So therefore the answer is 6X. If 1 PP bond energy is X. Clear? Now an excellent question, sir. What is the maximum covalency of nitrogen? Maximum covalency of nitrogen, how much? Yes. If you verify the structure of ammonia, N is surrounded with H, and it contains one lone pair. So covalency means number of covalent bonds attached to nitrogen. Therefore here covalency of nitrogen is equal to 3. But the question is maximum covalency. Sir, here nitrogen top and 2 electrons are there, sir. Therefore, it forms some other 2 bonds. If you check like this, yes, N make a bond with H, by using lone pair on nitrogen, it forms a D2 bond towards H plus. Then after that N is surrounded by H and D2 bonds towards H and N get positive charge. This is called NH4 plus. Sir, you told previous covalency means number of covalent bond. Here covalent bonds 3 only, covalency 3 nena. No, this D2 bond is also called coordinate covalent bond. It is also the type of covalent bond. Therefore, covalency of nitrogen here 4. Somebody have doubt, sir. Here 2 electrons are there. Why you make a 1 bond? Yes. To form 2 other bonds with the nitrogen, vacant d orbital required. By good luck, second period element, any second period element, any second period. So any element has no d electron. D electrons or d orbitals are not there. So therefore there is no excitation possible. That's why second period elements maximum covalency is 4 only. 4 only, sir. That's why in NH4 plus covalence of nitrogen 4. Somebody think like this, sir. If you check N2O5, sir, N2O5 low, sir, for oxygen 5 there, sir. So therefore covalence should be 5, sir. No. If you check the structure of N2O5, N double bond O, day 2 bond O, single bond O, single bond N, day 2 bond O, double bond O, like this. So therefore, on the each nitrogen surrounding bonds you count, there are 4 bonds only there. On the each nitrogen surrounding bonds are count, there are 4 bonds only there. Therefore, sir, if 8 are covalency, no. Covalency definition, number of covalent bonds attached to an element. That means one element. Therefore, here, covalency of nitrogen is 4, but not 5. Our feeling N2O5 contain 5 oxygens, therefore covalency must be there 5 like that. No. Here the covalency of nitrogen 4 only. Yes, sir. This is an excellent point related to covalency. Now I will ask one more question related to sulfur. In S8, what is the covalency of sulfur? Now if you check the S8 structure, it is called rhombic sulfur, like this. Crown shape is there. So it has a puckered ring structure like this. So this is each sulfur, check it, each sulfur attached with 2 other sulfurs. Puckered ring structure or crown shape it is called. So therefore covalency of sulfur is equal to 2. This is about the topic related to covalency. Next we discuss electrovalency. Yes. The previous topic is covalency, and that related covalency, how to find electrovalency, that we will discuss later. Now the ultimate topic in the chemical bonding is dipole moment. Yes, dipole moment is an excellent topic. First, what is a dipole moment? In name only there, dipole means 2 poles. Oh, 2 poles movement. Okay, it is a movement of the poles. So very excellent point. Dipole moment is a vector quantity. It is a vector quantity. That means it is depending on the direction. So if you take an example, C double bond O and double bond O. If you check this example, carbon and oxygen, there is a bond present. Carbon and oxygen. In that bond, due to more electronegativity of oxygen, it has partial negative. It has partial positive. Then between carbon and oxygen, the bond migrated towards this side. So the dipole moment, it is symbolized by arrow mark with the cross like this. This is a dipole moment symbol. Like this, if you take in this bond towards more electronegative side, this one. Suppose in this direction the value is plus x, this direction is minus x. Therefore, mu of this entire carbon dioxide is how much means? One direction is plus x, another direction is minus x, the net value becomes 0. So, the molecule whose dipole moment is 0, that molecule is called non-polar molecule. The molecule whose dipole moment is 0, whose dipole moment is 0, that molecule is called non-polar molecule. Non-polar. It is not polar. Non-polar molecule. Sir, I know non-polar bond, sir. Molecule also non-polar will come na? Yes, sir. The molecule net dipole moment is zero there. That molecule is called non-polar molecule. The molecule whose dipole moment value is there net, that is a polar molecule. Correct? Yes. Now we'll take the one more example. Then you got the idea about the polar molecule. Yes. Now an excellent example, excellent and outstanding example, ammonia. Ammonia. Yes, if you write the structure of ammonia, N, I already explained covalency in that concept, ammonia structure explained. N make a bond with hydrogen, N make a bond with hydrogen, N make a bond with hydrogen, and N has a lone pair. Sir, I have a small doubt arises in my mind. Is it lone pair is restricted between at a certain place? Is it lone pair is restricted between the certain place? Okay. So, between two members, if the electrons are sharing like this, everybody know this is a covalent bond, sharing of electrons between the two. Then these two electrons are exactly present between x and y. It is not present above the x, below the x, above the y, below the y, like that. Exactly between x and y. That means bond pair is restricted between x and y. But lone pair means the pair is present in lonely. Lonely means what? Restrictions. What restrictions? Nobody restrictions. Okay. Suppose you are present lonely in a certain place. You went to America. You are there in lonely. Therefore, nobody can restrict it. Will go anywhere. Anywhere, correct? So therefore, if you want to write the correct structure of ammonia, look at this. N bond with H restricted. N bond with H restricted. N bond with H restricted. But N has a lone pair like this. It not be restricted. It not be restricted. So the lone pair present on nitrogen, above that nitrogen, is not restricted, sir. It is there throughout, away from this. So therefore, again, we will discuss that ammonia structure. Yes, this is nitrogen, and in that hydrogen, it has lone pair. That lone pair has some movement is there around towards lone pair. N and H electronegativity towards N is more. N and H electronegativity towards N is more. N and H electronegativity towards N is more. That means here all are in same direction. So therefore, you want mu value, mu1 plus, mu2 plus, mu3 plus, mu4, you are adding, it is not equal to 0. Definitely it is not equal to 0. Therefore, ammonia is a what? Polar molecule. It is a polar molecule. Ammonia is a polar molecule. And one more doubt I have. Sir, ammonia is a polar molecule, correct? Is it have polar bond? Molecule is polar because net is not 0. Is it bond is polar? Yes, sir. Between two heteroatoms bond is came, that is a polar bond only. Between H and H, bond is non-polar. Between O and O, bond is non-polar. Between Cl and Cl, bond is non-polar. But between two different atoms, bond definitely polar. So therefore, ammonia is a polar molecule. Ammonia is a polar molecule with polar bond. Excellent question. Yes. Now I want to know about the mu values order for NCl3, NF3, NH3. NCl3, NF3, NH3. You know, this dipole, everybody think dipole moment very easy, sir. Just dipole moment related ammonia and NF3 like that. Recently in 2026 IIT advanced question given related to this dipole moment of nitrogen compounds. Okay, recent IIT advanced 2026, it happened on May, in 2026 May 17 it happened. On that day they are asked one question related to dipole moment. That means based on that you got an idea. Dipole moment is an excellent topic. Now, can you give the order of dipole moment for these three compounds? Yes, sir. Can you give the order for these three compounds? Yes. First, you write the structure N, bond Cl, bond Cl, bond Cl. It has a lone pair. Next structure N, bond F, bond F, bond F. It has a lone pair. Next, one more structure N, bond H, bond H, bond H. It has a lone pair. Sir, lone pair is there, movement towards lone pair only. Lone pair, lone pair, lone pair. Good. Now, N and F, electronegativity is more for F. So, towards F, towards F, towards F. N and H towards nitrogen, towards nitrogen, towards nitrogen. So, here some second case, some cancellation there. One is an up, other one down. Some cancellation is there. Even though cancellation, mu is not exactly 0. Okay. This one is mu1. This one is mu2. This one is mu3. This is not equal to 0. This is also not equal to 0. Mu1 you check. Mu1 you check. Yes, sir. Here, N and Cl. Excellent bit, sir. Excellent bit. Try it, sir. Immediately in your mind, try it. Try it on the paper. N and Cl bond migrate to which side? N and Cl bond migrate to which side? Sir, second example, bond is migrated towards fluorine, sir. Automatically here towards Cl, sir. By bad luck, electronegativity values are taken. N value how much you know? 3. Electronegativity values you check Cl, that is also 3. Oh, both are electronegativity values same, sir. Correct, sir. Both are same. Then bond migrated towards what, sir? Sir, bond is not migrate, sir, because both are same electronegativity, sir. Sir, this is look like a H and H bond, sir. This H electronegativity 2.1, sir. This H electronegativity 2.1, sir. So bond is not migrated this side or that side, sir. So it is non-polar bond, sir. Correct. It is a non-polar bond. It is non-polar bond. Correct. But even though N and Cl are having the same electronegativity values, this bond is not a non-polar bond. It is a clear polar bond because the atoms are hetero, na? Hetero atoms means different atoms. Then in these two bond migrate to which side, you know? In these two bond migrated to which side, you know? Yes, sir. Bond migrated towards small size side. Small size. And towards nitrogen. Yes, sir. That's it. And here also mu1 not equal to 0. Here also mu2 not equal to 0. Here also mu3 not equal to 0. But you check a clarity. Here mu1 not equal to 0. Here mu3 not equal to 0. Here mu2 not equal to 0. Why writing size, you know? Here third case all bonds are in same direction. That means mu value is big. In first case also all bonds are in same direction. And here also mu values are big. Correct? But second case some are opposite but not exactly cancel. And compulsory first and third, one is more, other one is next, the middle one is last, and floor NF3 is the last. But in these two, how to decide means, yes, sir. Based on the polarity, that means based on the electronegativity difference also, dipole moment value will come. So therefore, the topmost dipole moment order, NF3 is greater than, NCl3 is greater than, okay, NH3. This is wrong. NF3 lo F is there. Sir, F means more alternative, sir. Here only more there. No. Based on the cancellation you check, that will give the correct answer. The topmost is the last one, ammonia. And the next NCl3, least NF3. This is the correct order. The above order is wrong. Because why I am writing that one, everybody think, sir, fluorine, sir, highest alternative, sir. It's compulsory, more value there, sir. Correct. It's more value there. Okay. So, if you check dipole moment order for HF, HCl, HBr, HI. So, here only one bond there, So, therefore, electronic difference from fluorine only more value there, difference. Therefore, here dipole moment order, HF is greater than, HCl is greater than, HBr is greater than, HI. Based upon this example, and the above example also, students think NF3 is the top. No, sir. NF3 is not the top. Based on that explanation. I think you understood, sir. If you understood this, what the topic explained previous is covalency and this one, chemical bonding dipole moment. Okay. Through in this my channel, JJR Chemistry channel. Immediately you subscribe my channel and encourage to me. And I will make so many videos. If you subscribe and you the same video transfer to your friends, okay, automatically I will make more videos this coming month. Okay, I want to take more classes for the NEET point of view. Okay, sir. So take it. Be brave, sir. Be brave. I will be there in chemistry. I am there as a JJR. It is a JJR Chemistry channel. Okay, so if JJR given 5 star means it must be there. It must be there in our examination. Okay, it must be there. It is there in directly 2026 IIT advanced question. Clear? That is only simple logic. Okay, sir. In next video we will continue.